When the Concorde made its final landing in 2003, many believed supersonic commercial flight was gone for good, grounded by noise, high fuel use, and cost. Since then, aviation has focused on quieter, more efficient subsonic travel. But the dream of speed lives on. Denver-based startup Boom Supersonic is reviving that vision with sustainable, economically viable supersonic aircraft. At the heart of this effort is the Boom XB-1 demonstrator, or Baby Boom, paving the way for Boom's full-scale passenger jet, the Overture. Supersonic travel is making a comeback faster and greener than ever. Let's explore how Boom Supersonic is rewriting the future of aviation and bringing Mach-speed travel closer than ever. Breaking barriers, a historical perspective. The first person to shatter the sound barrier was Chuck Yeager, piloting the Bell X-1 back in 1947. That moment was not just about speed, it was a victory over previously unconquerable physical limits. Supersonic flight introduces a host of challenges far beyond mere velocity. The moment a plane pushes past Mach 1, it encounters intense aerodynamic pressure, extreme heat buildup on the fuselage, and the infamous sonic boom, a thunderous shockwave that can travel for miles and even shatter windows. When engineers took on these challenges in the 20th century, they were forced to confront not only the laws of physics, but also the realities of public dissatisfaction, high operating costs, and environmental concerns. While two major supersonic passenger aircraft made it to market, the Soviet Tu-144 and the Anglo-French Concorde, only the latter achieved commercial longevity. Even so, the Concorde's time was limited. Its services were expensive, its noise pollution disruptive, and its fuel use unsustainable. The end of the Concorde signaled the end of supersonic travel, at least for a while. A startup with supersonic ambitions. Founded in 2014, Boom Supersonic emerged with a bold mission: to develop supersonic aircraft that are sustainable, safe, and affordable for the 21st century. After participating in the prestigious Y Combinator program in 2016, Boom quickly gained traction, securing hundreds of millions in funding by 2019. Rather than leaping immediately into building a full-size passenger plane, Boom began with a scaled-down prototype, the XB-1. Dubbed Baby Boom, this demonstrator aircraft is designed for testing aerodynamic performance, materials, and flight systems. Its insights are shaping the future design of Boom's passenger aircraft, the Overture. The XB-1 Baby Boom. Visually reminiscent of the Concorde, the XB-1 shares its sleek, elongated fuselage, but on a much smaller scale, measuring between 62.7 to 68 feet in length depending on the source. It's a far cry from the Concorde's 202-foot frame. The XB-1's wingspan is just 21 feet, compared to the Concorde's 84 feet. It's a single-seat jet built for performance evaluation, not passenger comfort. Unlike Concorde's famous droop nose, the XB-1 opts for a simpler fixed-nose design paired with a glass cockpit. To counter visibility challenges caused by the aircraft's high nose and compact shape, Boom integrated auxiliary cameras that help the pilot with taxiing and ground operations, eliminating the need for a complex moving nose section while improving design simplicity. Material selection was crucial to ensuring the XB-1 could withstand the thermal and aerodynamic pressures of supersonic travel. Boom used carbon fiber composites, titanium, and heat-resistant alloys in its design. The tail section is composed of 90% titanium, while the wings feature high-modulus carbon fibers for strength and temperature resistance. Dutch-based 10-Kate Advanced Composites provided critical materials for high-stress zones like the nose and leading edges, which must endure temperatures of over 307 degrees Fahrenheit during flight. Powered by military-grade technology, the XB-1 is equipped with three General Electric J85-15 afterburning turbojet engines, the same type used in the Northrop F-5 fighter jets and T-38 Talon trainers. These engines collectively produce 12,900 pounds of thrust, enabling the Baby Boom to reach Mach 2.2 over 1,600 miles per hour with a range exceeding 1,000 miles. In terms of engine configuration, the XB-1 initially mimicked the intended layout for the Overture. However, Boom later decided the commercial airliner would feature four custom-designed engines for better efficiency, power distribution, and noise management. The future of supersonic passenger flight, scheduled to debut in 2026, Boom's overture marks the revival of commercial supersonic aviation with cutting-edge technology and sustainable design. At 201 feet long with a 106-foot wingspan, it's slightly smaller than the Concorde but far more advanced. Powered by 4 Symphony engines developed with GE additive, standard aero, and Florida turbine technologies, the Overture will cruise at Mach 1.7 over water, reach altitudes of 60,000 feet, and cover up to 4,250 miles. The Symphony engines are 100% compatible with sustainable aviation fuel, 10% more cost-efficient than older models, and designed to meet International Civil Aviation Organization Chapter 14 noise regulations, as well as Federal Aviation Administration Part 33 and European Union Aviation Safety Agency certification specifications for engines, underscoring Boom's commitment to sustainability and global compliance. The economic and practical impact. Boom expects the Overture to serve over 500 routes, focusing on transoceanic flights where sonic booms pose less of a concern. Projected travel times include Newark to London in 3.5 hours, London to Frankfurt in 4 hours, and San Francisco to Tokyo in just 6 hours with 1 refueling stop. While the aircraft's estimated cost is around $200 million high, but modest compared to modern military jets, passenger tickets are expected to be more accessible, priced around $5,000 one way, a significant drop from the Concorde's $12,000 fare, roughly $21,000 today, adjusted for inflation. Who's on board? Pre-orders and production. Between 2016 and 2022, Boom Supersonic received 146 pre-orders for the Overture from airlines including United Airlines, American Airlines, and Japan Airlines, along with several unnamed clients. The company plans to manufacture between 1,000 and 2,000 aircraft over the next decade, scaling production at its Overture Superfactory in Greensboro, North Carolina, a facility designed to produce up to 100 aircraft per year. In a surprising twist, Boom also partnered with Northrop Grumman to explore defense and special-purpose variants of the Overture. These specialized aircraft could be used for emergency medical delivery, rapid disaster response, and high-speed surveillance, offering the military capabilities no conventional aircraft can match. Supersonic milestones achieved. In December 2022, Boom began official testing of the XB-1. Its first flight took place in March 2024, and by January 2025, it became the first private non-military jet to officially break the sound barrier. Fittingly, this milestone occurred in the same airspace corridor where Chuck Yeager made history nearly 80 years earlier. The second supersonic flight occurred in February 2025, after which the XB-1 was retired, allowing Boom to fully focus on finalizing the Overture. And there you have it, the incredible journey from the Concorde to Boom Supersonic's Overture. If you're just as excited about the return of supersonic travel as we are, smash that like and hit that subscribe button. Thanks for flying with us today, and until next time, keep dreaming big, flying high, and chasing that sonic boom.